before kind of talking about the main subject, I want to tell you a bit about me and where I'm from. And I'm from the 80s. What I mean by that is I was born in the late 70s, so basically I grew up through the 80s. And grip through the 80s means you get to see all these weird computers. That was actually the first ever computers to reach the world of consumers. And this one you can see the Sinclair ZX80. And this guy here is actually pushing an extension card of RAM of 16 kilobytes. And that was very expensive at the time. You have also the Auric one. I don't know how popular it was outside of France, but actually in my home country it was quite popular somehow. And that was pretty good as an 8-bit computer. It had a number of graphic capabilities to display colors and actually show graphics on screen instead of just text. And that was a pretty good computer, except from the keyboard. It was kind of soft keys, very strange. You feel like you're touching food somehow. But it was somehow unique. And then came the computer that I think many people know nowadays because it was kind of ubiquitous at the time. Most people know the Commodore 64 because it was sold by millions of units around the world, in the US, EU, and even other places. And that had a strong following. Many people developed applications for it. And actually, there's still even a strong following to this day on this computer because it was so popular. But in the UK, they actually had something a bit different that was popular as well. Kind of a dinosaur version of the Commodore 64. That was the BBC Micro. And BBC Micro, you don't know why you call it Micro because it's more like massive than Micro. But somehow this was only sold in the UK mostly by a company called Acorn. And they did two different models, Model A and B. And don't try to look for differences, basically they look the same. But one had slightly better capabilities there compared to the other, and the price was different. And because of the price was so expensive in pounds, all this kind of stuff was only seen usually at school, where kids could actually learn on these computers. So many kids in the 80s in the UK, they start learning about computers through this kind of hardware. All right. And this kind of computer were plug and play computers somehow, because you just plug into a screen and you can start doing something with it. And when I mean doing something, it's not so much to do in the first place, because there was not so much applications available in the beginning. So that means programming. I mean, starting to learn how to program with your teacher, and experimenting with basic languages like BASIC, and going ahead to develop your knowledge about the computer itself. And like for example, the Commodore 64. It had a similar kind of concept. When you start the 64, you just reach a blue screen and it tells you it's ready. It's waiting for a command. It's waiting for you to enter any kind of instruction that will execute, whether it's loading something or even programming something. You can actually program in BASIC directly from that screen and actually run a full application, if you can do it, of course. And that's actually very different to what we see nowadays, where we're moving toward this kind of very visual, interactive, and very intuitive displays and computers, which basically are all about making it easy for you to actually consume contents. So I would call that more like consumption devices. And it's fine, it's fine to have both directions, but there's a guy called Eben Upton, who actually British, who lived through the same generation as me, and who has been growing through the same computers like the BBC Micro, and that kind of hardware, and he has learned about computers through this kind of way. And he wanted to bring back, this kind of spirit, this kind of experimenting with kids, in today's age of computers. And so he wanted to make something which is again plug and play, programmable, and basically as cheap as possible, so that many people can actually have access to it. And he came up with this kind of design with, his team, of course. And that's what we call the Raspberry Pi. You can see here one sample. You can have a look later if you want to see it in more detail. It's very small cards, and in terms of design, it's very simple. You have all the kind of equipment you expect on computers, like LAN and USB. You also have, of course, video and audio outs, and HDMI if you have digital outputs. And storage is through a SD card, and the power is through USB micro USB cable. So actually, it's very simple design, and it's based on very much widespread hardware that makes it cheap And it doesn't mean that because it's cheap, it's not powerful. Somehow, the GPU that's actually on this device is a video core 4 from Broadcom, and that's actually able to decode, full HD video. I wish I could do a presentation today, but unfortunately, I couldn't connect on that screen, so we have to wait for another time. But it's actually pretty impressive when you see. Actually, I can't do it either. But it's actually pretty impressive when you see like this kind of device in action and actually decoding, full HD video. It's pretty, it's pretty good. And in terms of models that this company is proposing, they're actually proposing 2 models, and it kind of reminds you of, what they did before, the A and B. They did the same thing. They went through calling the Raspberry Pi A and B and pricing them at 2 different, prices, $25 to $35. And you can see it's a level of magnitude lower that, the computers at that time, of course, but even nowadays computers much cheaper than that. And it's very affordable. It's basically the price of an Arduino One board. So you're thinking about it, you have a full computer for a price of a microcontroller board nowadays. And in terms of software, it runs basically anything that can be programmed for that. And usually you see Linux distribution. So you will have Debian. You have a number of other distributions like Arch Linux and OpenELEC. Recently, somebody actually also released Ubuntu as well as Android running on this. So basically, as long as you can program for this kind of hardware, you can actually run anything because there's no limitations. Question after.
Okay.
Keep your question. So what do you do with it? That's the question. What do you do with this little piece of of hardware? And first I want to kind of turn the question around what you should not do with it, or maybe like what you should not expect doing with this. First, you should not expect it's going to replace your laptop or desktop computer, because there's way too little RAM and there's way too little processing power to actually do something meaningful with it in that sense. For example, if you're running Firefox or Chrome, that's very much demanding application, and if you try to run something on this kind of hardware, you will see a major difference in terms of how fast it runs. So you won't be really enjoying the experience there. It's not going to be either an Arduino killer, because even though they're pretty much of the same price, same size, and somehow same kind of design, if you look at it this way, this is very much for a different purpose. The Arduino is actually a microcontroller, so it's used to control other hardware that's connecting to it, and through the I/O controls, right? And it's very low power. With Arduino, you can actually connect, battery on it, and you run it for like hours and hours, even days sometimes, depending on what you're doing with it. While for the Raspberry Pi, you need to plug it in, into the wall to make it sure it works. And this is more robust as well. It's been tested on the field for many years, and we know it's worked in many conditions. And there's lots of different configuration available because it's open hardware. So anybody who wants to make a compatible Arduino board can actually, do it themselves, and they can commercialize after that. So you can see a number of different Arduino boards available on the market to meet different consumer needs. But recently, there's been this kind of innovation on the Raspberry Pi. They released this kind of geared board that's, kind of increasing the capabilities of mimicking Arduino, maybe making it even better for I/O control. But we don't talk about this today. So coming back on what this can be, what the Raspberry Pi can be. Well, it can be a cheap media player because, as I mentioned before, it has a reasonably powerful GPU that can actually, do playback of Full HD. So you have XBMC distributions available for this one. And you can actually use it as a media player because it's silent, it doesn't make any noise, so it's actually pretty good for that. It can be a cheap NAS because you can connect your storage on this one, hook it to the internet connection and access the data wherever you are, as long as you're online somewhere else. It can be, of course, like for games, you can emulate lots of different systems from the 80s and the 90s and actually play Pac-Man on this one. And even more recent game from the 90s, of course, because it's powerful enough for that. And of course, can program on it, which is the first, reason why it was developed. And because of the Linux environment, you can actually do Python, all these kind of popular languages that's available on any Linux platform. And it's also good in a way because it's not very powerful. So when you're designing anything for that, you really have to think, whether the code will run well on this or not. And you will have to optimize to make sure it runs at appropriate speed. Almost finished. But I think where the Raspberry Pi is very changing, thing is, we are moving from an era where computers were kind of expensive. You were thinking about throwing $300, $400 to get actually a computer. And nowadays, with this kind of device, what's changing? It doesn't cost much anymore to have actually computing power at home. And it's very cheap, and you're moving into the realm of disposable computing. Because it's so cheap, you don't have to worry about destroying it, trying stuff with it. So there's a lot of experiments going on nowadays with the Raspberry Pi because it's so cheap, and you can replace it anytime. So that also means you will see this kind of device everywhere. It's going to be ubiquitous. It's very likely that people are going to try to hook this up on many devices that are not made for that currently. And you can kind of think, this is your phone. Like 10 years ago, you couldn't do much with your phone apart from calling. But just because you put computing power inside, you can do so many things nowadays with applications. The same thing can happen, with other devices around us. As long as you put the right power in the right device, you can, multiply the capabilities to do things. And we will see, probably more computing power everywhere, more hardware projects. So, kind of hardware renaissance from now on to power device to do more things everywhere around us. And I'm really looking forward to what's going to come up in the next year, 3 years from now. And it's only been less than 1 year that this has been released, and it's already had a major success on the market. And they have difficulty to supply, to many people. So it's off a great start, and I recommend you check it out.
For questions and any comments?
Yeah, sorry.
Have you actually run XBMC on that?
So you install a short script on this first, and then you connect to the Ethernet connection, and they will download the whole thing and install the SBMC for you directly.
Have you done it? Have you checked out the performance? And it's smooth.
It's smooth, except at the loading time. When it loads the script at the beginning, it's kind of like stuttering a little. But once you're in the movie, start the movie, it's fine. It's pretty impressive. Sorry.
Could you just highlight what the main differences are between that and Arduino? Is it mainly a power thing, or?
So power is main difference also, because the Arduino can run into a few milliamperes, while this one needs about 800, 900 milliamperes to run properly. If not, it could freeze, basically. But also, this is a computer board. This is a microprocessor board. The Arduino is a controller board. So you can't run complex programs, not very complex programs on Arduino, and there's no huge memory on it. So you cannot do the same things with it. And probably you can tell more about it. It's not that. No, you. Maybe you want to answer the question. Difference between Arduino.
Controller is this one. So there is no video.
That's right.
Input. There is nothing.
It's just the connect hardware.
You need to put your program here with something, and yes. And this one is computer.
That's a computer.
Right. Okay. This one is, I don't know, to drive for Christmas tree.
Any other questions? Nope.
Okay.
Yeah. Sorry.
Do they have any industrial applications so far yet? Not industrial, but
the only thing I've seen, which is kind of professional application, that you can actually send this to a kind of web host in another country, and they will host it for you, and they will use it at your web server.
Austria, right?
Austria, that's right.
Co-location.
Yeah, co-location. So, and they will do it for free. So as long as you provide the hardware, they do it for free for you. You don't have to pay any monthly, any fee or anything. So that's the kind of only thing I've heard. Maybe you've heard anything else?
You can use it for many stuff. The coolest one, I told them before, you can use it, not buy Apple TV, but use this guy, and you can, stream from your iPhone or iPad to the monitor.
This has Wi-Fi?
You can put Wi-Fi on the USB.
But with this XMBC, you can stream air server.
Oh, I know.
That's right.
Yeah,
you have lots of plugins for XBMC to expand.
Awesome.
has anyone put it in their car and done anything?
Yeah, I've seen that actually. Yeah.
That's
Like amateur project.
yeah. You could do that with someone. Drive for you. Google Maps.
I will buy a car when they drive themselves.
You have to plug it in, you can't, there's no way to hook it up to run a battery?
You can actually hook up on a battery. Like you have a kind of charger, USB charger for mobile phones, like kind of bulky ones with a USB plug, and you can plug it on this one, and you can run for like several hours with it.
Alright,
So there's a way to actually power it, even without plugging it on the wall.
Okay.
Thank you.